try to end today, but not really sure how hard it's gonna be. And I'm gonna try to talk about what I've been thinking about. So, but yeah, it's gonna take some time, I think, to organize everything. And yeah, so pretty much, since last time I streamed, I was thinking about studying Three.js and then figuring out what shaders they're using and implementing something from scratch with WebGL, and then implementing something with Three.js and then React through Fiber. And then I found another library which is called React 3 Rapier, I think, which seemed to be the best alternative for me because it's exactly what I'm trying to do, is to combine visualization with Rapier with the physics engine. But as I was trying to do that, I kind of changed my mind because I think that I'm already spending too much time on the visualization part, and the most essential thing and most challenging thing for the stuff that I'm trying to do is going to be to figure out a way to extract information from code and structure that information in a way that is going to be useful. And I'm not really sure how hard it's going to be. And ideally, I would spend at least 2 weeks, I think, studying, going really deep into compilers and interpreters, because in case I get accepted for the Nights and Weekends project, which is going to start next month with 5th of August, I think. Ideally, I would be able to start already knowing a bunch of stuff, so I can, during the nights and weekends, implement things and show progress, because I don't want to spend the whole period of nights and weekends just studying things, ideally. So I think that I'm already spending too much time on this part here, the visualization. So I decided to just try to implement with Three.js right away and not worry about the shaders. And then later on, maybe I'll go back and try to... I'm probably going to go back eventually because I do want to go more in depth into shaders and trying to understand how to optimize things. But then I implemented something with Three.js, a very simple graphics with a bunch of nodes and then lines connecting. And then I encountered a problem, which is that Three.js doesn't allow you to do lines with thick width. And I think that's because the way that OpenGL works. So it turns out that it is hard to draw lines with OpenGL. And then I think Pixi does that automatically for you. So the lines on Pixi are already have more flexibility on the width. So this is one problem that I encountered, but then I found 2 different solutions and I implemented one, and then I stopped there last time. And then today I was trying to implement the React 3 Rapier, but then I encountered a problem with Vite, that Vite, and honestly this kind of pissed me off, but they probably have a reason for that, that Vite only compiles the files, it demands that the files have a .jsx extension. And then some of the files on the React 3 Fiber are, some of the components use .js extension. So I was searching for how to fix that. And then it got me thinking, and also there were some really helpful responses, because when I was thinking about this, I was debating in my mind whether or not it's worth it to do things with React 3 Fiber, or if I should do things with Three.js imperatively. And this is the main thing that I'm still thinking about now, and I'm trying to figure out. But I think that I'm going to go with the Three.js approach, because it just feels a lot better to me, because it allows you to have more control, and it's just a lot easier to think about it. Because the main problem with using React 3 Fiber for creating the nodes is that you have to use ref hook in React to keep track of the nodes you build, because each node is going to be a component, and that's the declarative approach. You build everything with components, and then you do things that way, and then imperative approach is more building everything with classes and functions. And I think that the imperative makes a lot more sense to me, because it allows you to separate the function from the visualization library in the physics, and it becomes a lot easier to keep track of the nodes and the objects that the visualization has. And it becomes a lot easier to create events and to manage everything. And if you do with the declarative approach, it becomes really annoying because then you have to use ref, and then you need to use the context to access in different components. It just adds a bunch of complexity. And I was thinking about whether or not it's worth it. Yeah, because the main reason I think for using React with Fiber would be because of the benefits that come with the custom render that they have, which is a React reconciler configuration that is custom, that is different than the React DOM, which might optimize the way that React updates the components. But the thing is that I still don't know very well, but there were some really helpful responses here. So shout out to the people here on the Discord because they're very helpful. And those responses clarified a little bit, but I'm still not 100% sure. But from the responses that I got here, this one and some other ones, and from the prompt from ChatGPT, I decided that it's probably better to just go with Three.js for now, and then maybe later on do the React wrapper. And also, using React wrapper, there's this annoying thing with Vite that you have to figure out a way to put the customization on the configuration of Vite, but then they don't have anything talking about that on the documents. And I searched online; it's kind of hard to find. Try to implement a couple of the solutions that I found online, but none of them solved the issue. And then if you try to look into the source code of Vite, it's very complicated, and they do some stuff where they make the functions be just one letter. So it's like G as default config, and then you have to search for the letter G, but the letter G is everywhere. This is really annoying. And I don't understand why they do it like this. They probably have a reason. It's probably because of some stuff on the configuration or the way that they do the code for compiling and finding the imports. It probably makes it faster, I think, that just separate. But I don't understand why not put that on the documentation, like an option to parse the JS files, because and this is a problem that I always have, which is that with external dependencies, and especially a problem with TypeScript, that the more external dependencies you put, it's like there's not much you can do because it's outside of your control, is other people's libraries and code. And obviously, it's already a plus that you are able to use these libraries, so it's obviously already a benefit, but it then adds this problem where if you want to use their code, you kind of rely on them, and then you have to spend a bunch of time trying to figure out these problems that are not related to the stuff that you're trying to build. So this is something that I thought is really annoying and shifted more my choice to go with Three.js now, I think. But the main risk, I think, with going with this approach is that, and the biggest problem, I think, is that it might not be the best with React, with the way that React works. Because my main concern is that if you build with the imperative approach, is not aligned with the way that React is going to update the components. And if you use React with Fiber, I think that's the main benefit, and using the declarative approach, because they do have, like the guy says here in some of these responses, I think I'm going to read the responses because I thought that they were helpful. But he says that they built a bunch of optimizations, and you can opt into some of these optimizations and can also use components that are designed for that. So like they handle a bunch of code for you. But the downside is that it adds a bunch of complexity and is very annoying to write. So I think it's just better to try to keep as simple as possible and do the imperative approach, and then just create the components myself in case I feel like I need them. But it might be a problem later on, so I'm still not 100% sure which is the best way. But for now, I think that Three.js is probably the best, so I'm going to take a risk. And what I'm going to do right now is just try to refactor the code that I was using Pixi, and I got it to work the way that I wanted to work. And now I'm changing all the functions and classes that it's going to use here to build with Three.js instead of using Pixi. And there are some key fundamental differences in the way that they design the class, but I found that, at least for my taste, Three.js seems to be much better than Pixi. And what I think I'm going to do is just download the code locally here. I'm not going to use the node modules, I think. I installed with the node modules, but I think I'm just going to copy the file, and I'm going to put locally on my project because I want to have more control over the code. And the downside of having more control over the code is that you have to maintain the code yourself. But I think it's a good trade-off, and I think that just as with any problem, you're going to have this gradient, and the solution is probably the one that has the most complexity that converges towards infinity, because it's going to depend on the context of what you're trying to do, which is going to be the encapsulation of both sides of the symmetry. So in one end of the extreme, you would have where you do everything yourself, the whole code yourself. The downside of that is that you're going to spend a lot more time building the code, and it's going to be a lot harder to maintain the code. And the other extreme would be you create a package dependency for everything, and then you just use npm for everything. The downside of that is that you're creating more and more points of failure. So as things evolve, you don't have any control over the other libraries. And because of all the dependencies and everything like that, and because people are not coordinated, people don't coordinate well, because there's so many different projects going on and so many different incentives that people have. As time passes, it increases the likelihood that you're going to have a bunch of problems with the dependencies and the versions and things like that. So it becomes a lot weaker over time. It's not anti-fragile, I think. So in my mind, the best approach is for things that are fundamental to your application, you should probably create the dependencies, not create the dependencies yourself, but put the code locally on your project and then maintain the code yourself. And for things that are more, that are not so relevant, then you can rely on dependencies, and you can expect that you're going to have problems eventually. So this is like stuff like React and hooks and things like that, because the trade-off of the speed matters, I think. So it's not worth it to spend a bunch of time trying to figure out how to create everything yourself. But let me read the stuff that they said here. And I want to spend a bunch of time in the beginning today to talk about this, because I think it's very important. The more I learn about code, the more I realize that this is what matters, and that's what the difference is. And also another thing that I realize is that as time goes by, you don't need to write the code yourself. Like, you get paid for thinking, I think. So writing the code is not important. What's important is understanding how the pieces work and how to put them together in a coherent way, and that optimizes efficiency. So you rarely are going to do the code yourself because everything is already online. And if it isn't, someone else is going to do it, or AI is going to do it. So the part that matters is this part right here, which is the thought process and the logic behind the decisions you make, taking into account the context of the whole and the complexity of everything, and how you manage to think about the trade-offs. And yeah, so like, I think it will be interesting as well, because I'm going to try to go with this approach. And then if I might face problems today or tomorrow or eventually, then I'm going to be able to go back to this video and see the thought process that I had. And then it's going to allow me to learn more about fundamentally what might have been the problem with the way that I was thinking at the time. But I think that I'm on the right track, because like I said previously, the way that reality works is like a multifactorial spiral. So you usually end on the place that you started, but 360 degrees different. And I think that this is exactly what happened with me now, where I started with Three.js, and then I decided to go with Pixi, and then I learned a bunch of stuff, and then learned WebGL and everything, and now I'm going back to Three.js. So I think that this is probably most likely the best approach. The only concern is whether or not to use React Fiber or to use the vanilla Three.js, which I think the vanilla is the best option, because I'm probably going to try to optimize later. So the stuff that I asked here was, for the project that I'm working on, graph network visualization, it seems it would be easier to set up the physics engine, Wrapper.js, and the events if I use Three.js directly. So I'm wondering what are the main benefits of using React Fiber? What are the pros and cons? Is the main benefit a performance gain that comes with the custom fiber renderer? And this is I was referring to the custom reconciler that I have, because that's the main point, I think, of having the React 3 Fiber. So the way that it works is that React Fiber is just a wrapper on top of Three.js. And what they do is just create components on top of the classes that Three.js already have. And another main benefit is that they create a custom React reconciler, which allows them to put customizations on what functions React is going to call at different parts of the fiber work loop, which is the loop that React does to update the DOM. So there's the diffing algorithm, which is just the navigation of the virtual DOM. It's going to compare different nodes of the DOM, just see if they need to be updated or not. And then there's a scheduler and there's concurrent work, I think, as well, which is just the logic that is going to select. You have the fiber, which is the class that is going to be updated. Is going to update the state of the DOM. And then the reconciler is the stuff that, like the name says, reconciles the previous state with the new state of the application. So it just navigates the tree, the DOM tree, compares the states and see if it needs to update or not. And then as it does that, it calls a bunch of functions that are going to mutate the DOM or not. So like append child and things like that. And when you have a custom React reconciler, it allows you to select what's going to happen. So to replace the functions from the normal way that React does this, which is with React DOM, with your new way. And the reason why this might be better is because then there might be some hidden, or not hidden, like some implementation that they do inside of these functions that allows them to optimize the efficiency in which React updates the elements of the canvas, because there might be some function or something with shaders that I'm not aware of that they can do that would increase performance a lot. And that was what I was thinking about. But I think it doesn't work like that. The canvas state is like its separate thing. And the only place that it matters is on the initialization, because on the initial initialization of the canvas, it's going to mount the elements, and as it does that, it's going to put everything that is going to happen on the visualization. Or let's say if you change the visualization, if you change the props or the props are the children, then it's going to mount the component again, or mount the component again. And then you might have a difference if you use a custom reconciler or not, because it's going to change the way that React updates the component. But this is not... it doesn't interfere with the interactivity of the visualization itself, I think. The only part that I'm not 100% sure is with the events, because there is some complexity with the events as well that I don't understand really well. And he briefly talked about it on his response, but I don't understand very well how it happens. But as far as I understand, you have the events that happen on the React itself, on the DOM itself, and those events are handled by React. And then there's a way for you to opt or to create events around the canvas itself, which would be just the state of the drawing. And then if you do things like that, the events would be non-blocking, which means that they wouldn't block the updates of the DOM. But if you let the DOM handle the events, then the events would be blocking, which means that every time that an event happens, it would block the state of the application until the event finishes. So in that sense, it would be better to separate the work and use the custom reconciler, because the custom reconciler allows you to handle events in a better way. But I still don't understand very well. This would be one benefit of using the React Tree Fiber, but I don't understand very well if it is very important or not. And I guess I'll figure out once I have more experience and I build this stuff, but yeah. So how much of an impact does that have? What would be the downside of using Three.js directly and setting everything up on the function inside the useEffect hook of a normal React component, which was what I was doing before. And I think it is what I'm going to do now with Three.js. You just create a separate function and then you call the function, or you create a separate class, call the function or class inside of the useEffect. And then on the return statement of the useEffect, you delete the class or dispose everything. And then you just create one component that has a wrapper for the canvas. And then you pass the reference of the wrapper to the WebGL renderer. And then you build everything just on top of that component. And then the other way, yeah, we're creating everything directly with Three.js, messes up the visualization because of the rendering cycle of React. So this is what I said. So his response was, this will work, but only grow complex as you relate your sync to React state. It becomes very difficult to track async effects this way. And this is a part that I mean that I don't understand very well what he means by that. So you want way to split up concerns so they're free to update as separate effects. React is very good at this, and Reactor Fiber lets the reconciler do the work here, which is very memory efficient compared to a naive or lack of a scheduler. Paul has some practical demos of this with the scheduler, since a lot of this was formalized with React 18. All internal updates are non-blocking except for user land state calls, which are blocking unless you make them async with start transition and the like. Practical scenario, there are memory efficient abstractions like ECS if you can share states. Not 100% sure what this means, but I think it stands for Entity Component System, which is a paradigm from game development that I don't not really familiar with. So I don't fully understand these responses here, but I got from the feeling of the responses, the feeling that I got is that there isn't that much of a difference in the optimization, in the speed of the visualization, and the only main difference that you would have is on the events and managing the events as the application becomes more complex. So that's the main difference, I think. So that difference, it made me think that for my case, it's not worth it to do this trade-off, because it just adds a bunch of complexity and also makes me lose flexibility, and later on it's going to become more difficult, I think, to refactor everything and try to optimize. So let's say later on I want to create my own shaders that are custom shaders, and that to increase the efficiency of the visualization for specifically what I'm trying to do. Then I would have to refactor everything if I use Reactor Fiber. But if I use vanilla Three.js and I have the code on my local project, I just copy the code and put on my local project. Then I can go into the source code and I can change things in whatever way I like. And I think that feels a lot better to me, because I like having that control. But as well as a balance, like I said. No, it completely depends on the updates itself. That's what I mean. In this case, there would be a significance because the diffing will change since their reconcilers will be different. So let me go back. Yeah, so this is another thing that I was wondering with events. So the way that I was thinking about is that every time that an event happens, I'm not 100% sure if React is gonna diff again the tree to see if something changed. Let's say I drag a node. If React is gonna diff the tree to see if there was a change, or if I add the nodes, more nodes to the visualization, stuff like that. I wasn't sure if that would trigger the reconciler and then it would make a huge difference with using the custom reconciler or not. And then he said events are outside of React and now is non-blocking, otherwise they will compete with each other. I'm not 100% sure what he means by that. So because I don't understand what events he's talking about here, I think. If he's talking about some custom events that the Reactor Fiber has, or handles the diffing and only on a state update, which is deprioritize. And this is what I asked. In this case, there would be a significant difference between Fiber and vanilla Three.js, because the diffing would change since the reconcilers would be different. No, it completely depends on the update itself. If you're changing one property, it would be a straight mutation, same performance. So I assume what he's talking about here is that just changing the props the custom reconciler wouldn't have that much of a difference, which is the main case that I was thinking about. Because when you add nodes, it's gonna cause the React to update the element, and then when it does that, it's gonna call the reconciler. So it could be the case that there was a large difference because they did some optimizations on the custom reconciler. But from this response, it seems like it doesn't have that much of a difference. It doesn't do anything deep or expensive. If the update itself is expensive, such as deletion or disposal, you'd benefit from memoized history, which doubles as convenience for real-time HMR or jank-free scene management. Not 100% sure what this means as well, but I think he's just talking about the inside of some of the functions on Reactor Fiber, they use the use memo hook, which allows you to memoize the state of the variables, of some variables in some situations. So I think that he's referring to this. And I think this would be a performance gain, but it is not significant enough, I think, to make me want to use the reactor fiber instead of doing vanilla Three.js. And then the other stuff that the guy says here, he also shared a really interesting thing that I didn't know, and I'm going to try to see if it works, which is 2 different events you can use to track mouse drag. These events here, I didn't know that this was possible, but it looks like it is. You can call this set pointer capture on the target of the event, and that makes the mouse be captured without having to create flag variables, I think. So you just do this and this. So you do this on the mouse down and this on the mouse up. And on the mouse move, you just change the thing. But I'm not really sure if I'm going to use this or not, because I already have the code that it works on the other one. So I'm just going to, initially I'm just going to try to refactor only what's necessary to make the visualization work with Three.js. Because the relative coordinates are very annoying. I think that's one of the biggest problems I'm going to have now. Because the way that I was doing with Pixi, I'm changing the coordinates of the main container. And then from the change in coordinates, I calculate the relative coordinates. And that allows me to keep track of everything that is happening on the scene. So I can maintain the functionality of the events. But the problem with Three.js is that the way that you create the components that are going to create the visualization is slightly different. So it's not like you create a whole container. It's more like you create, in Pixi JS, you create a main container, and then I did all the visualizations inside of the main container, I think. And on Three.js, you have to create a specific, let's say, small container for each node. So it's like you're creating a bunch of containers, and then, but I think what I'm going to do is just change the main scene. Yeah, I'll figure this out once I start working on that. Shows you what code is said. The performance increase is also due to the ecosystem. In the real world, Fiber cannot perform vanilla not only because of React scheduling, but because complex performance optimizations are available as dropping components. Yeah, so that's what I meant. It says you can access all these components here, which already have a bunch of optimizations. But in my mind, I think that for my case, it's not worth it to deal with the annoyance of making the nodes and the rafts work with the declarative approach. And I can just download the library eventually in the future, download the reactor fiber, and then see how they did the components, and then just translate that to the imperative approach and incorporate on the stuff that I'm doing. So it's more work, but I think it's worth it because more control and flexibility. As now that I got, I think I talked about everything that I wanted to talk about. So I'm gonna start trying to refactor this. This is the code that I had from the other project. I changed some things here already, but what I have to do is figure out how to change all these functions so that they work with Three.js. I think I'll be right back. I talked a lot. I think I'm gonna put music for myself. Kinda tired of talking already. So, but I think it's worth talking about this stuff because I think it is the most important thing. The rest is kind of a trivial, I think. Like it might be difficult, but like it's not the most important part, I think, of building the thing. And the more, like I said, the more I code, the more I realize this. Especially nowadays, I think that back in the day it was probably more important to code, but nowadays, and I think in the future, it's going to be more and more important to understand the macro perspective and the complexity of everything and how everything connects together, and then figure out the best way to put the pieces together instead of coming up with everything. I think I'm gonna delete the walls because it's not necessary. Just from the example that I got, I'll delete the players. It's gonna be very annoying to figure that out. I think that the problem is I'm not gonna be able to use frame, so I'm gonna do things with request animation frame, I think. This part's gonna be hard as well. So I think I need to add to the render. This is the canvas. So when you create this, it creates the canvas inside of the WebGL render. So I think I need to append, but that's the problem because it's gonna be different here. And I think this is the main issue because of the events. So the way that I was doing Pixi is I just append everything to the container and then I change the position of the container. But here I have to append to the canvas. I think maybe I append to the scene instead actually. Yeah, I think I put the elements of the scene. So maybe if I change the position of the scene, it's gonna be the same thing. I just pass the scene instead of passing the container. I think the other difference is the way that the visualizations are done. I'm gonna have to change this. Let me think about what's the best way to start. Oh, I don't need this because I'm already using the sign. Maybe you should just put the music very... Hopefully they don't take down the stream. So I created these two functions here to create the nodes and the edges. I just implemented this approach because it's easier, but I'm not really sure which one is better. So the way that it works is that you draw the lines with triangles because OpenGL can't draw the line. For some reason that I don't understand really well, but... So this is like the workaround if you want to create thicker lines. And the line that Three.js has is too small, I think. But maybe in the future I should allow to have the option, because obviously if you draw the smaller line, it's going to be faster. Because every time you have to draw a thicker line, you're going to do multiple different triangles. But I think Pixi JS does the same thing probably, because it's an issue with OpenGL. And probably an issue with the shaders and the GPU. So I think maybe first thing I should do is just put the functions here. I think I'm gonna change the way that it is here as well. Maybe. Because I don't like very much initializing this stuff inside of this function and then returning both of them. I think it makes more sense to initialize outside. Yeah, but it's gonna depend on the way that the function works. A difficult part is understanding how to do this with the physics. Because this is the main difference. The Pixi, you just create these graphics here, and then you draw from the graphics. But on Three.js, you draw directly. You create the geometry. Mesh, I think, is a bunch of triangles, so it's just a way to create a structure, like a surface based on triangles. And it seems like game development, that's how they do it. And then the material is the specifications of the stuff that you're drawing. But maybe this one is not the... Oh no, it's the edge that has the width. So let me think about it. I'm doing this on the... Oh no, the animates. So this is another thing that I'm not really sure. Is if I should call the animate here, or if I should initialize the request animation frame, like initialize outside and just return the function. And the problem is that another issue is that I need the delta time, I think. So I have to see how to get that from Three.js in order to update the physics engine. It's kind of overwhelming because there's a lot of stuff to think about in the beginning here. I'm not really sure which part to start with. Because the problem is that it's not gonna work when I initialize the thing. I'm just gonna delete this. Or maybe it's this thing that I wanna pass. I think I'll mute the events first, think about the other stuff. Not gonna be render. So instead of this, it's gonna be this. I think you just copy this stuff here. And this I'm gonna put inside of the functions. I think it's fine to leave like this, I think. And to initialize the request animation frame inside of this function. Oh, I already have container though. So container will be this thing, I think. And here will be container. So I think that the only thing I have to change here is the text and the style. I haven't looked into how to create text yet, Three.js, but I suspect it's more annoying than Pixi, because you have to. I think I've seen some stuff about it. So I'm probably gonna have to look at the documentation. The challenge here is that there's so many things to change that it's kind of hard to think about what is the first thing that I have to change. Like, what is the best approach? And also, like, I want to see if I can. I'm gonna have to change the way that this is here as well, because it is a different approach, I think. Because here I have to create a new geometry for every circle. I think that's the difference And then here I was just creating a graphics component and then putting all the circles inside of the graphics component. But I think probably the Three.js way is better, I think. Because if you want to customize, and I'm definitely going to want to customize at some point, then it's better if everything is separate. So, but I think it becomes harder because then like I have to figure out. I think when I draw the nodes, I'm already gonna have I'm gonna have on the nodes property the cycle. Yeah, so instead of putting this stuff here, I'm gonna put it inside of the loop here. In each node, I'm gonna cache the circle on each node here after I create, like I'm doing here. And then when I do that, I can access here. So let me remember, because I think that here I'm creating the position from the physics engine. So I have to see how I was doing to draw from this position. I get the body and then I put the position from the... So I call the function on the thing. This is a fundamental difference as well, I think. Well, actually not, because I'm gonna run this on... Yeah, I'm gonna run this on the loop, I think. But this is the issue. It's because I don't want to create the circle each time. I just want to create once, and then I set the position later. So I think this is the fundamental difference. As here, I create in the beginning, I create the physics in the beginning, and then I do the drawing based on the physics, because I'm just creating once here. But the new way, I have to create the drawing of the circles in the beginning, along with the physics engine. So I think it's better to just initialize them on the same function. So I initialize everything on the same function. And then I initialize first the physics and then the circle with the position from the physics. That's the best way, I think. So how can I do that? So I think after here, I already have the thing, so I can do in the same loop, I think. So I create the physics, and then I'm gonna have on the node, which is gonna be from the physics. I think I'm gonna comment the label because I don't wanna worry about this stuff now. I'll do that later. Because I wanna think about one thing at a time. The other annoying thing is the coordinates here. Gonna be a problem. I think I can delete this because I was just doing this to... because of some other stuff that I was doing that I don't remember. But I think I can delete. So I create the node. Oh, but let me think. Yeah, I think I have to loop again, because the issue is that I need to have all the nodes positions. Maybe not. Maybe I can just grab from this node. Yeah, maybe that works. And I think this should be the name instead of the ID. Let me think about it. So here I think I'm gonna have to instead of setting to this, I set to the position of the physics. So node body translation. Yeah, like this. A node body translation. Oh yeah, the radius has to come from the thing as well. How do I do this? So this comes here. Oh, this is the problem. I think, yeah. Because the thing is that with Three.js the dimensions are different, I think, the values that they put there. So I did under 50 because if I didn't do that, it was just too big. But I think I can set the radius for a different dimension. Maybe I'll set here. This might be a massive problem, which is the way that Wrapper does things and Three.js does it. But I think it should be fine because there is the library, the React Wrapper, so obviously it should be a way. But I think I can just set the radius here after I create if it's too big. And then this is the number of segments, which is the number of triangles that it's gonna use. The greater the number, the more it looks like a circle. Yeah, I think it should work. Yeah, but let me think about this. I should probably create another function to update the circle. That's the thing. And then when I update, I just set the positions. It will be the same that is happening here. Just copy this function. But maybe I should comment out the edges for now and just focus on this one so I don't get overwhelmed. So instead of nodes graphics, I'm just gonna store this on the node. So I'll do this inside of this function. And then I'm gonna have to see the method. But I think I don't need to clear. And this is gonna be different as well. I don't need to do this stuff, I think. And then here I will change. Yeah, I think that's pretty much everything that I need to do. So I think that's the one fundamental difference, where in Three.js you create everything in the beginning and then you just change the visualization. And on Pixi you have to redraw each time. But maybe it doesn't work. I think I'm gonna comment everything out, and I'm just gonna try to see if this works. And the problem is I need to figure out the delta as well before, I think. Or maybe I just call the step without anything first. See if it works. Circle translate X. I think setting position is better. Create the nodes there and I update here. Let's see if this works. Probably there's gonna be a lot of issues. I think I'll grab back. I think I also need to import here as well. Forgot to do that. Oh, this is not... Did I change the wrong file? I think, yeah. Maybe I confused myself there. No, it's here. I forgot to delete this. Let's see if I need... Yeah, I think I don't need Three.js here. Oh, I need here. I don't understand why it changes now. Maybe I'm importing the wrong way. Yes, probably a typo. Oh, just using the .js extension, so that's what's wrong, I think. You can go right back. Obviously, it's using Pixi somewhere, so I have to delete. So I have to figure out where. Or right back. Where is getting this stuff from? And if I just delete, I promise. Like, I'm not calling that on the one, but maybe it's parsing anyway. I think the edge is probably gonna be the most annoying to figure out. The edges in the event. It's probably because of the angel, maybe? Or the events. Maybe you should just comment out this. There's some parts that is using Pixi, but I'm not sure where. This is from the other project, I think. So here, it's probably this one. But the thing is that I'm commenting this out, so... But maybe it's parsing anyway. Node graphics. This is an issue. Yeah, let's shoot canvas. And this happens because of the way React updates the DOM, I think. It runs the user fact twice. I have to think about a way to stop this from happening. I think it's not showing there because of the class. Because the CSS here. Don't understand though why it's not, why the root doesn't show. I don't understand why though. It's not. It's probably because of this display block here, but there were a couple of times that this happened as well. You know, other things that I did. Let's see if I remove from here, what's gonna happen. Interesting. It should be working with this here though. Oh, now it's working. Or maybe it was working, or just hovering over the other one. No, let me see. It should be importing there, and so it is working. It was just hovering over the wrong. Obviously, I don't care about this stuff because I'm just trying to make it work. Once I make it work, I'm just gonna copy the code to the other project. I think the other one has CSS. I'll probably just copy here. And finally. And now I have to... I think I had this problem before as well, where I was creating two canvases. So how can I solve this? Let me see if there is a method to remove everything from this. I think there is a dispose method. And this is the problem, is that I should probably return here then the animate function. I return the animate and the renderer, and then just run the animate from outside. Because I need to access the renderer from the other place, so I need to return from here. But I think if I call, let me see if I just return, it's gonna allow me to. I think after I figure everything out, then I'm gonna just put the library locally and refactor stuff. But I want to figure out one thing at a time, I think, otherwise it's overwhelming. Yeah, dispose. But I think it doesn't remove the canvas. That's the problem. It just removes the event listener. I guess I can manually remove. Just render DOM elements, remove child, and then, or the container remove child and then pass the thing. Let's see if this works. It's not a function. It's probably because it's not returning the same thing. Yeah, that's the issue. Let me think about this. I think this one is async because of the physics engine. So I can put Dan here. Oh, I have to return, I think, probably. Or maybe not, because... And the issue is... I don't want to make... I think making async on the use effect function is not going to work either. I have to put the curly braces on. And it's not gonna work. Yeah. I want to see how they do it with the React 3 wrapper. Maybe I'll create a project with Next.js just to see, to implement and see their code. Just see, because I'm not really sure about this. I think it's not probably correct to do it like this. But it has to be async because of the wrapper, because it uses WebAssembly. I think that's not gonna work. And the problem is the way that, which was my concern in the beginning, the way that the React's gonna update the components. Maybe if I do the return async as well. The issue if I do it like this, if I declare the variable there, is that it's not gonna work. It also feels wrong to do it like this, where declare the renderer there and just assign. Yeah, it doesn't. That's the issue. So obviously the other thing that I can do is just create another function and just make the function async like they say there. Just await here, but like I call this inside of the function await, but I also think it's not gonna work because then I have to make it equal inside of here, but then it's not gonna be aware of that variable in here. So I think the other alternative is to pass something here and then make that thing equal to the render. But I also think it's probably not the best. Because I think what is gonna happen is that this is gonna be async, so it's not gonna matter. Because it's only gonna assign the variable once the other stuff runs. Which means it's not gonna have access here. You can pass a function and then call the function inside of the other function as well. So let me think about it. I think I'm just gonna have to spend a bunch of time thinking. Probably I'm just gonna stop here and do this off stream. I'm gonna think and research. Just see if there's a way. The problem with doing the React tree wrapper is just gonna take a lot of time. Because then I'm gonna have to initialize another project, install everything, and then go over their code and spend a bunch of time trying to understand how they do it with the component. The question is, if I have an async function inside of the use effect, how can I dispose from the return of the function? I think if I just remove the canvas, it's gonna be bad as well. But I can't even do that if I don't have the renderer. I need to access the renderer to... Because what I'm planning on doing is just, I think is remove child, the name, and then I just pass the canvas here. And that's gonna fix the issue there. That there's two canvas, hopefully. But I need to figure out a way to call this async function, get the value, like make the code wait for this. And this is the most annoying part, because I think it doesn't matter how I call, I have to do it inside this function, but then in the scope inside here it doesn't have access to outside. So there's no way to get this value and call it here. That's the problem. And I think also using the user states is probably not going to work because I would have to set inside of this function. Yeah, I think what I have to do is look at the React Fiber code and then see how they... But I remember it's like very complicated. It's gonna be annoying to... Because I have to look inside of the component and then I have to see how do they unmount the canvas. But it's very annoying, like the way that they do it, to understand. It might be just a waste of time. And I wanna try my best to try to make it work like this, because I think it's gonna be much better. It's just much easier to understand. The use refs are very annoying if you're gonna do declarative. I prefer the imperative approach much more, I think. A lot more. You know, the biggest problem is this of the async function, which I already suspected because it's the whole thing about the cycle in React. But if I manage to make it work, I think it's much better, much easier. If I manage to do. And if I don't, then I'm gonna have to go with the React Fiber approach and React Wrapper. But I think that there must be a way to make this work. You just have to spend more time thinking. So the fundamental issue here is that the function is async and I have to access the value that is initialized inside of this function here. And the problem is that the way that React is going to work, I think it's going to run this function at some point and then it's going to cache the values. I don't remember really well how it works. But I know it calls this function at some point. So this probably has to be synchronous. Oh, this is the issue. And I think, but there should be, I think what I'm going to search for is, because it should be a very common problem. And I think there might be another hook that I can use, like the use query or the other ones, because it's very similar to problem of data, where you're making a call to an API and the call is going to be asynchronous. So there's probably another hook that I can use or something like that, because it's the same pattern, I think. You want you want to get something async and then you want to dispose that. But that's the issue, is that it's slightly different because with APIs you can put the data, you can set the state inside of the then statement here when the promise returns, but here I can't do that because I have to access on the return statement. I think it's slightly different. I think I'm gonna do this offstream when I search for this. So the plan is to try to make this work. If it doesn't, then I'm gonna see how I can make it work with React Fiber or React Wrapper. But ideally, I'm gonna be able to do it with this way, and then I'm gonna finish refactoring everything from Pixi to Three.js. And once I have all of that, then I'm gonna start studying interpreters and compilers. And then maybe later on, I will see if I have to change or... And this is the biggest thing that I still don't know, is that it feels like it's more incentivized to do the React Fiber way, because it is the React style of thinking, but at the same time, it doesn't. From the stuff that I've seen, it doesn't seem like there is a lot of performance optimization, and it just adds a bunch of complexity. So I think the imperative approach is much easier and much better, more flexibility, more control. But then the biggest issue is the fundamental problem with the way that React updates everything and the way that the function is going to run. This is the biggest challenge. And the problem is that it's extremely annoying to understand the React stuff, which I kind of understand now after studying a bunch of the source code, but still like very annoying. And what I'm planning to do later is to just use the stuff that I built to study more React later. So once I'm able to do the visualizations. Yeah, but that's the biggest problem, which I don't know for sure. But I think I'm gonna do this off stream because I'm gonna have to spend a bunch of time thinking now and researching this stuff, probably reading the documentation, looking the source code of Vector Fiber. I'm probably not gonna come back in a long time. I'm gonna try to finish this off stream. Then once I do, I come back and probably once I'm able to figure out with Three.js, I'm gonna, the next step is to create the customization component that is gonna allow you to change the properties of the visualization, so the physics and the stuff from an outside component. And that's probably the next thing that I'm gonna do on stream. And then after I finish that, then I can start studying compilers and interpreters. So see you next time.